The James Webb Space Telescope has spotted a planet that could be better for life than Earth, Jupiter, or even Venus. K218b, sitting 124 light-years away, has scientists buzzing with excitement. Could this distant world hold the right conditions for oceans, air, or even creatures we've never seen before? Tune in, because what James Webb uncovered is the confirmation of life outside our planet. For starters, K218b is no ordinary planet. It's what experts call a sub-Neptune, meaning it's bigger than Earth, but not as enormous as Neptune. Picture something over 2 times Earth's size with nearly 9 times the mass. That alone should make it interesting. But the real hook? It's sitting in the so-called habitable zone. That's the sweet spot around a star where conditions might allow for liquid water, the most important ingredient for life as we know it. However, just because it's in the right spot doesn't mean it's a paradise waiting to be discovered. Before we dive deeper, what James Webb uncovered on K218b is far more astonishing than anyone expected. And this is only the beginning of what will leave you speechless. Scientists first got excited about this planet in 2019 when Hubble detected water vapor in its atmosphere. That was already a game changer. Then James Webb stepped in and found even more. Methane and carbon dioxide, 2 gases often linked to biological processes. Add to that the absence of ammonia and things start getting really interesting. Some experts now think this could mean K218b has a massive ocean hidden under a thick atmosphere. A planet covered in endless water. That sounds like a sci-fi movie, but it might not be far from reality. There's even a term for planets like this: Hycean worlds. These are water-rich planets wrapped in thick hydrogen atmospheres, possibly warm enough to support microbial life. If true, K218b wouldn't just be habitable. It could be a thriving alien ocean world. But here's where things get tricky. What if the planet is more like a small Neptune than a giant ocean? Some scientists think its thick atmosphere could create crushing pressure, making it anything but inviting. Others argue that its red dwarf star could blast it with radiation, stripping away any chance of a stable environment. Then there's the problem of actually proving life exists there. Right now, all scientists can do is analyze light passing through the planet's atmosphere, picking out hints of different gases. Even with the best telescopes, that's like trying to guess what's inside a box by shining a flashlight at it. Could the methane and carbon dioxide be coming from living things? Sure, but they could also be the result of non-biological chemistry. It's a question with no easy answers. Technology still has a long way to go before we get the kind of answers we're looking for. Right now, our view is blurry, like trying to see through a foggy window. But as telescopes get more advanced, scientists will be able to study the air around this distant planet in incredible detail. They'll look for certain gases that could mean life is possible and check if they are in just the right amounts. These future tools will also help experts understand the planet's weather, how hot or cold it gets, and how it reacts to the powerful energy coming from its sun. Every tiny piece of information brings us one step closer to answering the biggest question of all. Could this world really support life, or is it just another lonely rock floating through space? Now imagine for a moment that this planet, K218b, really is habitable. What if beneath its thick, swirling clouds, an ocean stretches for thousands of miles, hiding creatures unlike anything we've ever seen? What if, deep in its dark waters, life has been thriving for millions of years, unnoticed by the rest of the universe? The thought alone is enough to send chills down anyone's spine. For centuries, humanity has looked up at the stars, wondering if we are truly alone. If this planet holds life, even the smallest microorganism, it would shake the very foundation of everything we believe about our place in the cosmos. Finding proof of life beyond Earth would be one of the greatest scientific moments in history. It would change how we see ourselves, how we define life, and how we approach the search for other worlds. No longer would the idea of alien life belong only to science fiction. It would be a real, undeniable fact. Governments, scientists, and explorers would race to learn more, to send better telescopes, and maybe one day, even a spacecraft. The discovery would force us to rethink what it means to be alive in a universe so vast and unexplored. And if life exists on one planet beyond our solar system, how many others could there be? But for now, we wait. The next generation of space technology is coming, and with it, the potential for answers we've never had before. Will we find something astonishing hiding in the depths of K218b, or will this world turn out to be just another disappointment? Are we on the edge of something incredible, or are we simply dreaming too big? Whatever the case, this search isn't slowing down, and neither are the questions that come with it. Finding water vapor was exciting, but what scientists discovered next made the search for life even more surprising. K218b has been making headlines, and for a good reason. Scientists spotted some pretty interesting gases floating in its thick atmosphere. The James Webb Space Telescope caught traces of methane and carbon dioxide, which got people talking because, on Earth, these gases are often tied to life. Some experts even started wondering if this distant planet could have liquid water hiding beneath all that hydrogen, making it a possible home for life. Then, things got even wilder when researchers thought they detected something even more exciting: dimethyl sulfide. If that name doesn't mean much to you, here's why it matters. On Earth, this stuff is mostly made by tiny ocean creatures, which means its presence elsewhere could be a serious clue that something is alive out there. But before anyone starts claiming we've found extraterrestrial fish swimming around, there's a problem. The detection of dimethyl sulfide isn't confirmed yet, and if science has taught us anything, it's that nothing is certain until it's double-checked 1,000 times. The challenge? Space telescopes don't just snap a quick picture of a planet's atmosphere and label everything floating around in it. Instead, they pick up light signals, and those signals can be messy. A single molecule can be mistaken for something else, and some gases share a lot of the same characteristics, making it tough to say for sure what's really there. Let's break down why dimethyl sulfide is such a big deal. On Earth, this gas comes from ocean life, tiny organisms breaking down compounds and releasing it into the air. It even plays a role in shaping our weather by helping clouds form. If K218b really does have this gas, it means something is either making it biologically or through some strange, unknown process. But here's where things get tricky. Non-living processes can sometimes create the same gases we associate with life. Scientists have already found ways to create dimethyl sulfide in lab experiments using only chemistry, no life needed. So even if we do confirm its presence on K218b, it doesn't automatically mean aliens, it just means we have a new problem to solve. And then there's the question of what kind of planet K218b actually is. Scientists call it a Hycean planet, which basically means a water-covered world wrapped in a hydrogen-heavy atmosphere. Sounds like something out of a sci-fi movie, but it's a real possibility. If K218b really does have a global ocean hidden under thick clouds of gas, it might be one of the best places to search for alien life. The presence of methane, carbon dioxide, and possibly dimethyl sulfide only adds to the hype. But there's a big difference between could be habitable and definitely has life, and right now we're stuck somewhere in between. Of course, finding out what's really going on with K218b isn't easy. The tools we have now, including the James Webb Space Telescope, can only do so much. Scientists are dealing with faint signals coming from an exoplanet located light years away, and even small errors could completely change what we think we've found. If methane overlaps with other gases, it might hide or distort dimethyl sulfide's signal, making it impossible to confirm without better technology. Right now, all we can do is gather more data and hope future instruments will be strong enough to separate the real evidence from the noise. To get closer to the truth, scientists are already planning follow-up observations. They need instruments with even higher sensitivity to really dig into K218b's atmosphere and figure out what's going on. If they can confirm dimethyl sulfide is there, the next step would be understanding whether it's coming from life or some weird, unknown chemical reaction. Either way, it would be a massive discovery, either proof that life can exist in extreme conditions, or proof that we still don't fully understand chemistry on alien worlds. Now, with experts studying strange chemicals in space, the search for life is becoming more interesting than ever. The whole search for extraterrestrial life has changed a lot over the years. People used to think the best place to look was a planet that looked exactly like Earth, with oxygen, nitrogen, and a climate similar to ours. But now the idea of Hycean planets is opening up new possibilities. What if life doesn't need Earth-like conditions at all? What if it thrives in hydrogen atmospheres, swimming around in deep, steamy oceans under thick clouds? K218b is testing everything we thought we knew about where life can exist, and that alone makes it worth studying. Scientists have been asking a big question for a long time. If we find something that looks like life out in space, how do we know for sure? It's not as simple as spotting a tiny creature waving at us. Instead, scientists search for specific chemical signs, things that life produces and leaves behind. One chemical, dimethyl sulfide, is interesting because on Earth, it only comes from living things. But space is a tricky place. Just because we find dimethyl sulfide on another planet doesn't mean life is there. There could be some unknown way it forms without life, and that would lead to a huge misunderstanding. Imagine scientists getting excited, announcing, "We found life," only to realize later that it was just another strange chemical reaction happening in an unexpected way. No one wants another case of, "Oops, that was a mistake." That's why studying a planet like K218b is such a big task. Scientists don't just take one reading and make a quick guess. They use space telescopes, computers, and lab experiments to understand what's really happening. The James Webb Space Telescope gathers light from planets far away, and that light holds important clues about what's in their atmospheres. But figuring out what those clues mean is a slow and careful process. Scientists build computer models to test different ideas. What if the planet's air has a mix of gases that create the same signals we're seeing? What if there's a way for dimethyl sulfide to form without life? To answer these questions, they do lab experiments on Earth, trying to copy what might happen on other planets. It's like putting together a huge, complicated problem, except the pieces are scattered across the universe, and some are still missing. Every small detail matters, and a single mistake could send scientists down the wrong path. The exciting part? We're getting closer to real answers. Science and technology are moving faster than ever. Telescopes today can do things we never imagined just a few decades ago, and even more advanced ones are being built right now. In the next few years, new space missions will give us an even better look at planets like K218b. These missions will tell us more about what's in their atmospheres and whether chemicals like dimethyl sulfide are really there. If scientists find it and can't explain it in any other way, then we might be looking at the first real sign of life beyond Earth. But if it turns out to be a mistake, that's okay too. It just means we have to keep searching. The universe is unbelievably huge, filled with countless planets, and the idea that Earth is the only place with life. That would be the biggest surprise of all. While K218b has amazed scientists, the telescope that found it went through many problems before it could change how we see space. The James Webb Space Telescope was supposed to be the crown jewel of space exploration, the biggest leap forward in uncovering the deepest parts of the universe. But let's be real, this thing was a financial and technical headache from the very beginning. It took way longer than planned, cost way more than expected, and had everyone on edge wondering if it would even work once it got up there. The idea was simple: build a telescope that could see farther into space than anything before it, capturing light from the very first galaxies. But getting from an idea to a fully functional billion-dollar space observatory was anything but simple. Back in the early 1990s, before Hubble even had a chance to prove itself, scientists were already dreaming about its replacement. They wanted a telescope that could see in the infrared spectrum, meaning it could cut through clouds of cosmic dust and spy on galaxies from the dawn of time. Sounds amazing, right? The problem was, the technology to make this happen didn't exist yet, but that didn't stop them from getting ambitious. By 1996, the plan had evolved into what was first called the Next Generation Space Telescope. They wanted it to have a massive 26-feet mirror, way bigger than Hubble's puny 7.8 feet one. The bigger the mirror, the more light it could collect, and the deeper into space it could look. But here's the catch: a mirror that big couldn't just be launched into space in one piece. Rockets simply aren't big enough. So engineers had to come up with an idea: make the mirror in pieces, fold it up like a piece of origami, and then hope it would unfold correctly once it got into space. If that sounds risky, that's because it absolutely was. It meant they had to develop a system that had never been done before. On top of that, the telescope had to operate in freezing temperatures, completely shielded from the heat of the sun. That's where the sun shield came in, a gigantic 5-layer structure the size of a tennis court, made of a super-thin, heat-resistant material. If even one layer ripped or didn't deploy right, the whole mission would be in serious trouble. In 2002, NASA officially renamed it the James Webb Space Telescope, honoring a former administrator who played a huge role in the Apollo program. But this was no Apollo rocket. The JWST was a completely new beast, and building it took way longer than anyone expected. The telescope was supposed to launch in 2007. Then it was delayed, again and again. Technical failures, funding issues, and the sheer complexity of the design meant that each new target date got pushed further into the future. By the time it was actually completed, more than a decade had passed, and the cost had ballooned to an eye-watering $10 billion. One of the biggest challenges was the primary mirror. Instead of a single, solid piece, it was made up of 18 hexagonal segments, each one crafted from beryllium, a metal that stays stable in extreme temperatures. But here's the thing: getting all those pieces to work together perfectly in space was like trying to align 18 tiny moving pieces in zero gravity from almost 1 million miles away. Every single part had to be tested, retested, and then tested again under conditions that simulated deep space. And even then, there were no guarantees it would actually work once it got up there. The European Space Agency and the Canadian Space Agency both played big roles in getting the telescope off the ground, literally. Europe provided the Ariane 5 rocket to launch it, and Canada developed a special guidance system to help it stay locked onto its targets. But just getting all the parts built and shipped to the right places took years. The final assembly didn't even start until 2018, and the testing phase was brutal. Engineers had to shake it to simulate the violence of launch, blast it with sound waves to mimic the rocket's noise, and freeze it in a vacuum chamber to make sure it could survive in deep space. Finally, after 25 years of development, it was ready to go. The launch happened on December 25th, 2021, from a spaceport in French Guiana. The world held its breath, because let's face it, this thing had to work. There was no fixing it once it was in space. Unlike Hubble, which could be serviced by astronauts, JWST was being sent way too far for a repair mission. Everything had to unfold perfectly, or the entire project would be a $10 billion mistake. For weeks after launch, scientists on Earth nervously monitored its progress. The sun shield had to deploy correctly. The mirror had to unfold and align itself. Every instrument had to come online without a hitch, and somehow, against all odds, it worked. By July 2022, the telescope sent back its first images, jaw-dropping, high-resolution glimpses of the universe that made all the delays and budget overruns seem almost worth it. Could K218b be the next Earth, or is it hiding something far more shocking than we can imagine? Tell us what you think, and remember to like and subscribe for more.